Hello and good morning and welcome to our AWS IoT Web Day. My name is Philipp Sacher. I'm working here as a solutions architect at AWS, and I will show you a little bit about our AWS building blocks for IoT applications. So all the sessions which we will have today in this webcast Web Day will be recorded and published on YouTube. You will receive the links to the sessions so that you can also later on have another look at all the sessions. Okay, so then let's get started. If you have any questions, then you can send them via the chat, and we will answer these questions in the end of the session. Okay, I will show you the some building blocks for IoT applications that you can use in the AWS ecosystem. And today, sorry, okay, my PowerPoint wasn't working correctly. Excuse me for that. So yeah, today many companies or people in nearly every area try to connect physical things to the cloud to build so-called IoT applications. That can be applications in connected home or smart home to steer, for example, heaters, to switch light on and off. You can have IoT solutions in the transportation area for connected cars, or perhaps in the production area for monitoring sensors, for creating applications to do predictive maintenance. You can also collect data in the healthcare service and so on. But I think IoT is a well-known term these days, and many customers have built already solutions with AWS. We will have also a session later on with use cases from our customers, and other customers or companies are about to start building applications. And I will give you now an overview of the AWS services that you can use to build IoT applications. Because if you want to build an IoT application, you do not only have a message broker where you collect messages, for example, but you will also do something more with the messages. So if we are looking at the services, so I will come to all the services a little bit more in detail later on. If we have our devices, the devices that are sending messages containing, for example, sensor data or any other data, they are connected to our IoT services, either, for example, AWS Greengrass or AWS IoT. And when you are collecting data, then you want to do more with your data. You want to store your data, you want to analyze and visualize the data. Perhaps you want to write applications to control devices that are connected to the IoT service. And we have a lot of services which you can use to store your data, like Amazon S3, Glacier, or RDS, which is relational database services. Then you can analyze or visualize your data with a lot of services, like with Kinesis streaming services, with Redshift data warehouse, with a Hadoop cluster, with a BI tool named QuickSight, with Athena, or with the Amazon Elasticsearch service. But I will come in detail more to all the services during that sessions. If you want to create backend application or companion applications, we have services like Lambda, API Gateway, or DynamoDB, and also the Mobile Hub, for example, to create applications, mobile applications where you collect data from, or where you visualize data from your devices, or where you can send command to your devices, and you can also integrate machine learning in your IoT solutions or applications. So then let's have a look to our AWS IoT service. Yeah, so our strength is that we are focusing here on security, and nearly every service that I have given an overview just is a so-called serverless service. That means you do not have to manage any servers or operating systems or something like that. You simply can consume the service. You can create, for example, and stream in minutes. You can really start within minutes to connect devices to the AWS IoT service. And the AWS IoT service allows you to use a lot of other IoT services than, so to see, or so to say, the front door to all other AWS services where you want to store, analyze, and visualize data. You can nearly use any chipset or operating system to connect your devices to AWS IoT, and you will only pay for what you use. So let's have a look at the technical details of the AWS IoT service. So we have, first of all, here in the bottom of the picture, a so-called thing registry. And the thing registry, you can register your devices, you can assign attributes for your devices. Might be you have temperature sensor would have other attributes compared, for example, to a light bulb. And then we have our device gateway. You will connect your devices to the device gateway, and you can do this with in a TLS connection with X509 certificates and mutual authentication for the authentication purpose. And we have also so-called AWS IoT policies for the authorization, because you have to authorize a thing that you connect to the AWS IoT service to fulfill actions within the service. So without having attached a so-called AWS IoT policy to a thing or to a certificate of the thing can't do anything. So you have to allow with a policy, for example, certain things to publish messages or also to subscribe to messages. And by the way, we have here within the IoT message broker, we support the MQTT protocol. I will also come in one of the next slides to the methodology of publishing and subscribing messages. And then we have also here a so-called device shadow. The device shadow is a JSON document to set and retrieve states from devices. And this is a persistent storage. So that means you can send commands, for example, from your applications here to a device which is connected to the AWS IoT service or which is not connected to the AWS IoT service by using a so-called device shadow, because the message in the device shadow will persist, and even if the device is not connected, when the device comes back online, it can read out of the device shadow. Then we have a component in the service which is called the so-called rules engine, which makes it easy to transfer data which are coming into the AWS IoT service to other services, or also to republish messages to other topics. I will also come in one of the next slides to the rules engine. Okay, then let's have a look at the publish and subscriber mechanisms within the AWS IoT service. This is we support here the MQTT protocol, and that means you have devices here which can publish messages to certain topics. You are nearly free to create your own topic structure depending on your application, depending on your needs. And you might have also devices which subscribe to certain topics. So you can see MQTT as a publish subscriber protocol similar to a mailing list. Nearly anybody can subscribe to a mailing list. People are sending messages to a mailing list that is publishing messages, and you can enter messages, but you have not to do And when building an IoT application, you might have, on the one hand, devices, as I already mentioned, which send messages to AWS, to the message broker, and you have devices which are subscribed to certain topics. And you can, for example, have devices subscribed to, I would call it something, control topics or topics for software updates. And they are listening on these topics, whether they get a message to do a software update, firmware update, or something like that. Now we will come to our rules engine. So with a rules engine, you can create rules on messages that are sent to the MQTT message broker. And these messages should be present in JSON format. Why JSON? Because with a JSON format, you can use pyhsical statements to extract parts of the messages. So only certain values, for example. Without using JSON, you can simply select the whole message. And then you can do something like a select star, but you cannot have so sophisticated rules compared to using SQL. And we have a lot of SQL also functions in the SQL dialect, which is used here. And what you can do, you can create a rule, for example, by defining what values should be read from which topic hierarchy. And then you can define so-called actions. And the actions could be, for example, that you send your data to S3 to store the data, or you can send the data to DynamoDB, or you can send the data to a Lambda function. That means you can process the data, because Lambda is a service with which you can run code in the cloud without the need to provision servers and something like that. You simply upload your code in the cloud, and the Lambda function is triggered by an event or by a schedule. And in this case here, an event would be a message that comes into the AWS IoT service that is then processed by the rules engine, and the rules engine is then calling a Lambda function. You can also ingest your data to a Kinesis stream. You can create CloudWatch alarms, CloudWatch metrics based on your data. And you can also call machine learning from rules that is meant to call the machine learning endpoint to make predictions based on your data. Okay, then let's go a step further to the messages. Yeah, you can filter messages with certain criteria. For example, let's assume you have something like a temperature sensor and you want to be informed if the temperature exceeds a certain threshold. Then you can define a message, select, for example, temperature, device ID, from a certain topic where temperature is greater than value X or lower than value epsilon. You can also move messages simply to other topics. Perhaps you have special topics where devices are listening to or applications have subscribed to, where you want them to republish messages to these other topics. You can transform also the payload of the messages. You can, for example, calculate in 25 sums, something like that. And you can react based on messages. And that's a really easy way to move data and to analyze data without the need for you to write any code or to write systems. For example, if you don't have a rules engine and you have purely a message broker, you want, for example, then to get certain data from a topic, then you have to have some mechanism that is subscribed on the topic that reads the data from the topic, processes the data. You need to write your code here, and here with the rules engine you can do a lot of things without writing any code. So, and I don't see SQL statements as writing code. Okay, and now let's have a look at the AWS IoT Device Shadow. The Device Shadow is simply a JSON document where you have the states of devices, and every device that you connect to AWS IoT can have a device shadow. And to give you an example, if you have a light bulb and you want to switch the light bulb on and off. So the message flow would be, if the light bulb comes on, it reports its state to the device shadow. Let's assume the light bulb is on, then it would report that the state is light is on. So then you can have an application with which you want to switch the light bulb off. That means you will send then a message to the shadow service of to the device shadow of this light bulb and tell the shadow service a so-called desired state, and the new state should be off. And if the light bulb is subscribed to the device shadow, it will read this message and has then to react based on the contents of the message. That means in this case to switch the bulb off. So let's assume you have an intermittent network connection, and when you send the command, the light bulb is not connected to AWS IoT. Then this message will simply stored in the device shadow service, because normally if you have a MQTT message broker, a publish subscriber system, so if a message is gone over a topic, that's away. So you don't, and if a device is not subscribed and cannot read the message, it will still simply miss a message. And here with the device shadow stores the message, and as soon as the light bulb comes back again and connects to AWS IoT, it will read from the device shadow if there is any change, and it will see in this case, okay, I got the message to turn the light bulb off. Then it will turn the light bulb off and report back the new state. That means light bulb is off. And that is a use case for the shadow service. Okay, then we have another service which is called AWS Greengrass, because AWS IoT is a so-called service in the cloud. And with AWS Greengrass, we extend processing capabilities to the edge. That means to devices. We bring cloud services outside of the cloud to devices. And what are the components of the Greengrass software? So Greengrass is a software, it's not a hardware. We have certain requirements for your hardware that you need to fulfill to run the Greengrass software on it. And the Greengrass software brings, on the one hand, a MQTT message broker on your device. The Greengrass software itself is also connected to AWS IoT. And you have lambdas that you can run on the Greengrass device. That means you can have now the chance to run lambda functions outside of AWS on edge devices. You have also local shadows here in the Greengrass software, and you have also local security integrated. That means the devices that you are connecting to your Greengrass software will also use X509 certificates. Okay, one component of the Greengrass system itself is a so-called Greengrass Core. And the Greengrass Core is the component where the Greengrass software itself is running on. It is responsible for the messaging, for the device shadow. A Greengrass Core runs at the local message broker and is also responsible for executing Lambda functions. When we started Greengrass back in June, we supported Lambda functions written in Python. And as of September 20th, we have published a new Greengrass version. And with this version, we also support now Lambda functions written in Node.js or in Java on your Greengrass core. Yeah, what are the minimum requirements to run the Greengrass software on your core? You need a single core CPU with at least 1 gigahertz, at least 128 megabytes of RAM. We support x86 or ARM and Linux, Ubuntu or Amazon. You can, for example, make experiments and try to set up Greengrass on a Raspberry Pi 3. That works. You can also use, for example, an Amazon EC2 instance and simply try the software there. And yeah, you can do whatever you can calculate on AWS Greengrass. And with AWS Greengrass, if you have, for example, devices that need to communicate in something like a local network to each other, then you can avoid the latency going for every message to the cloud. So you can create solutions, for example, where you really need low latency for device-to-device communication by connecting then your devices directly to the Greengrass core. And also part of the Greengrass software is a deployment mechanism, and that means you will create all your configurations for a Greengrass group within the AWS cloud. That means you will also create your Lambda functions in AWS, and then you will deploy your configuration and your Lambda functions from the cloud to your devices. So that means a deployment mechanism is already built into Greengrass. Yeah, and now I will give you a little bit more details about the services that I mentioned earlier that you can use to build IoT applications with the AWS ecosystem. Yes, so first of all, we have S3. That is an object store where you simply can store nearly any amount of data from anywhere on the web. You don't need to provision any storage. You simply can use the service. And our recommendation is, if you create applications where you collect data and you store data and process data, so to decouple the storage of data from processing of the data. So best would be to store the raw data on S3, for example, and then use other services to process the data on S3. We have also Glacier, which is an archiving service. It's extremely low cost, but it has a longer retrieval time compared, for example, to S3. And by the way, S3 is integrated with many other services that have native interfaces to S3, like EMR. This is a managed Hadoop cluster, or for example, like Amazon Athena or an Amazon QuickSet, which can directly access data which is stored in S3. We have Amazon RDS. This is a relational database service where you simply use a database. You don't need to maintain database software. You don't need to operate the underlying operating system below the database software. And we have several database engines that are supported here, like MySQL, like MariaDB, MS SQL, Oracle, and Postgres. Then we have our streaming services, Amazon Kinesis. Now we have one streaming service within the Kinesis family that is called Firehose. And with Firehose, you can load streaming data directly into AWS services. And might be you can remember the rules engine. You have seen that you can, for example, transfer services directly with the rules engine from AWS IoT, for example, to an Elasticsearch cluster. But if you have a lot of data, to make the transport more efficiently, you can use a Firehose stream, because the Firehose stream batches data together and sends data in batches into the Elasticsearch cluster, what would be more efficiently. And that would give you also another chance to do analytics with Kinesis Analytics. You can then create real-time analytics on a Kinesis firehose or on a Kinesis stream by simply using standard SQL statements. And we have streams. You can simply, from nearly every source, capture data, transfer the data by a stream, and create consumers that process the data from the stream. And yeah, from your point of view, all these services are serverless. That means you simply consume them. And as I mentioned already, no servers to manage for you. You can simply start using all these services nearly within minutes. We have then also Amazon Redshift. This is a data warehouse. When you want to create reports, you can use Amazon Redshift. We are also providing then Amazon EMR, which is a managed Hadoop cluster. You can start a Hadoop cluster, process your data, and when you are done, you simply shut down the cluster. That means you will only pay for the usage of the cluster if you really need to use a EMR cluster. And then we have Amazon Athena. This is a service which makes it easy to query data which are stored on S3. You can use a SQL-like language to query data that is stored on S3 without the need to have a database in between. And then we have Amazon QuickSight, which is a business analytics service where you can get insights of your data, you can create visualizations, you can do ad hoc analysis, you can step back in time in your data. Yeah, and then we have also the Amazon Elasticsearch service. This is based on the open source Elasticsearch service, but you don't have to manage the servers. We are doing this for you. And one thing which is really nice here is a built-in Kibana dashboard in the Elasticsearch service, where you can create your own dashboards and visualize your data. Yeah, then we have AWS Lambda. You simply run code in the cloud, or you can run the code on AWS Greengrass. Meanwhile, we have an API gateway which you can use to create unique interfaces to your backend systems. We have an Amazon DynamoDB, which is a NoSQL database where you can store unstructured data, and it's designed and built to scale even at high load. We have also a AWS Mobile Hub. These are solutions that help you to create mobile applications. For example, if you want to create a mobile application that accesses your IoT devices, you can use, for example, the Mobile Hub for that. And we have also Amazon Machine Learning. That is a service that makes it easy for you to create models for machine learning, for example, to detect anomalies in your data. You create a model, and then you can use your data and you can make predictions based on that model that you have created. Okay, so now we have heard a lot about services that you can use, and to give you an overview or a picture, what could you really build very fast to get started with an application? Here I have an example architecture, which is a sender dashboard with a notification. So you have on the left-hand side your sensors, which are ingesting data to AWS IoT. And then we use rules to send this data to Amazon Kinesis, in this case to Amazon Kinesis Firehose, and to transfer this data to an Elasticsearch service. And we can build the dashboard that you see here based on the data that are transferred to the Amazon Elasticsearch service. And while the data is passing the Kinesis Firehose stream, we can attach a Kinesis Analytics application. That means we can, in this example, what I have created here, look for a temperature maximum over a certain amount of time. So when you use Kinesis Analytics, you can make queries over time windows. If you use the rules engine from AWS IoT, you can simply have a look at a single data set. But might be you want to have to avoid getting alarms at only peaks, for example. You want to have the average temperature or the average of a value over a certain amount of time. You can use Kinesis Analytics for that. And with Kinesis Analytics, you can do nearly real-time analytics of your data while they are transferred here over a Kinesis Firehose or also over an Amazon Kinesis stream. Then, in this Kinesis application, if the sensor temperature here exceeds, or not the temperature, the humidity exceeds a certain threshold, then the result will transfer to another Amazon Kinesis stream. And logically seen on the end of the stream, we have a Lambda function which will process the data that arrives in the stream. And we do know that only data that can be seen as an anomaly will arrive in that stream. And then this Lambda function takes the data set and calls Amazon SNS. Amazon SNS is a simple notification service, and then sends an email to a certain email address. Yeah, and you could build such an application more or less in some hours. You can start really now. You simply need to create an AWS account, and you can consume all the services that are shown here. And to leave now the PowerPoint slides and go to the console, I can also show you a little bit how this application would look like on the AWS console. So this is a console for the AWS IoT service, and we have a built-in MQTT client into the service. So that means you can subscribe with these MQTT client to your topics. And perhaps you can see here that sensor data are flowing over certain topics. I named them telemetry, then the device ID of the device, and then sensors. You see here I have connected two devices to AWS IoT. You see here the data are formatted as JSON. You can see apart from the temperature, humidity, depending on sensor, also a pressure, for example. You can see the location and many other values. But for our application, we do not want to collect all the data, and therefore we have created a rule to transfer the data to Amazon Elasticsearch service by using Amazon Kinesis Firehose. So you can see here I have created multiple actions. That means you can also use one rule to store your data in multiple locations or transfer your data to multiple locations. And you can see here, this is simply a SQL statement where we select the thing ID, humidity, temperature, location, and datetime from a certain topic here. So if you have a look at the data here, we have a temperature, thing ID, and we have other values. For example, the IP address, it's not interesting for this application, and therefore we can benefit here from the rules engine and can extract data. Now let's have a look at Amazon Kinesis. Here I have created an Amazon Kinesis stream, and you can see here in the monitoring section of the AWS console for Amazon Kinesis Firehose some monitoring metrics, for example, the incoming bytes, the incoming records, and so on. One moment. I see already questions arriving. Okay, and then we can go to the analytics console, and here you can see I have created a SQL statement where I read the thing ID, max humidity, and max temperature. That means I use a SQL function to get the maximum humidity, maximum temperature over a certain time window here, and only if the temperature, only if the humidity is above 65. And here you can see the data that are coming into that stream, and they are presented like a table in a relational database. And so you can create your SQL statements based on this virtual table. And then we have here the result. We had here one result, one peak, where we had a humidity which was above the threshold which was defined, and here data will only arrive here if you have data that exceeds the threshold. That means this here is a source data, and then we have the destination. In this case, the destination stream is the stream where you send the data that are produced if you have data which exceed your threshold, and then you will get an alarm. And last but not least, we have here the Kibana dashboard, which is built based on this data. So you can see here, we had already peaks, humidity peaks, so I forced to have a little bit more humidity in the air to give you this example here. And here you can see two devices. We have for each device the humidity. We have also the temperature for the device, and you can see a graphics for that. Yeah, it's I have also created an overview of the maximum, minimum temperature, average, the same for the max humidity, min humidity, and average humidity. I have also integrated a map here where you can see where the devices are located. And I have created also another overview for device connections. So how many devices have connected, disconnected. So to get also an overview what's happening on the service. And you can also have something like the last will and testimony monitoring, that if a last will and testimony is sent to the AWS service, then you can monitor also these data years. So because you can do this if you have a device which disconnects unexpectedly from the AWS IoT service, then you can publish a so-called last will and testament message. And if you have a lot of these messages that are arriving, for example, but that you can see here on your dashboard, then might be there's something within your network. So it's an approach to monitor device connectivity. Yeah, and that's all done by using the services, or some of the services that I have showed to you. That's nearly done without writing any code. The only code which I wrote was on the device to read sensor data and to transfer the sensor data to AWS IoT. Okay, so far the demo, and I will now have a look at your questions. There are some questions. I have to look at the questions. Is there a simple service available to change policies for many sensors at once? I think you mean the policies for the sensors within AWS IoT. So you can, or we have an API. So if you want to change policies, you can use that API. In this case, you can script something here. So there's no mechanism where you can create new policies at once for every device, but depending now on your setup, if you have a single policy for a lot of devices, you don't need to create an IoT policy, an AWS IoT policy for every single device. You can have, for example, one policy for all devices. And if you change that one policy, then it will be changed, of course, for all the devices. I hope this answers the question. So the messages or the shadow itself can be deleted, and then also the messages in the service, but the service maintains the last message. So every message gets a version, and then you should have a message or a state within the shadow that reflects the current setting of your device. But you can also delete and recreate the shadow. The advantages of the device shadow, it is to control, for example, devices, and also to make sure that messages reach the device even if the device is not connected. If you think of, for example, you use cars, and cars might be driving through tunnels and so on, and they lose then the network connection, or they have mobile networks which are perhaps not in every area where you are moving reliable. Then you can use the shadow service to assure that your messages will reach the device, because if the device comes back online, it can query the shadow and act based on the data in the shadow. So what do I have? We have another question. Are there AWS partners based in Germany who can do kind of bootstrap IoT workshop in order to enable customers with the AWS IoT environment? Yeah, we have a lot of partners also in the IoT area. In this case, if you are interested in AWS IoT, I would recommend reach out to us. We have account managers which you can contact, and then they can proceed further. Or also, we as a solutions architect, we help our customers also to come on board with AWS IoT. And we have also a lot of other teams within AWS which can also help you, perhaps depending on the size, building prototypes or doing really the work. And we have, of course, also partners. Okay, then could you give more details about physical connection devices to device shadow, RESTful service? The connection to AWS IoT in general for devices is created with a TLS connection, and within the TLS connection you will use the MQTT protocol, and you will also use the MQTT protocol to communicate with the device shadow. So let me have a look at the next question. Do you need to explicitly specify the schema of the incoming messages? One day you want to add another field. No, you don't need to specify a schema. There's no schema checking. You should assure, if you want to benefit from the rules engine, that you have JSON. And perhaps I can come back here to my example. You see, I have different sensors which are sending different kind of data. So So like a little bit like a different schema. We have here, for example, other data for the one device compared to this device here. So you have here, for example, also a pressure, because this is a device that is equipped with more sophisticated sensors. And we have here another device which has only humidity and temperature, and they are all flowing through the same topic hierarchy, and I use one rule to extract value from that messages. Okay, that was it. Do you have your own implementation of MQTT, or do you use, yeah, we provide AWS IoT as a service, and we support MQTT 3.1.1 with some differences from the MQTT standard, which are documented. So you can look up that in our documentation. How is IoT connectivity from China to EU West node? That's a good question, but I think it's more about the network connectivity. If you can, or if you are allowed to connect from China to EU West technical scene, it's one thing, but I think there are more restrictions with connectivity from China. So I would recommend reach out to us, and we can discuss this in detail also with our colleagues from China. Okay, where can I find the YouTube movie and this other presentations? Yeah, we will send the links and so on after the IoT Web Day. Okay, I don't see any other questions here. Then thank you for your attention. And have a good day, and have fun with all the other presentations from our partners and from other solutions architects. Thank you.